Translations. Objective by in this lesson, you should be able to graph functions using translations, apply translations to given points to find new coordinates. So translations just something we've been doing since the beginning of graphing. So in this example here, you have f of x equals x squared, some people call it the parent function. And then what we're going to do is we're going to move it left and right. So if you remember from class, inside affects the x values, and you want to do the opposite of what it says, opposite operation. Outside affects the y values, and you follow what it says. You follow the operation. So something like this would say move right h unit and move up k units. And in this context, it's x squared, so it looks like this, right? Inside the parentheses, we x minus h plus k. This will be my inside. This will be my outside. So if you have so on the graph, you see this. Here's our x squared. We're going to move using this formula. We're going to move to h and k. So right, a positive h, inside opposite, and up k. So right h and up k, and we get the point right there, our new vertex. The graph goes like that. So this shifts the vertex from parabola from the origin 0, 0 to hk. The key thing here is that the x value, the h value, the inside affects the x values, and the outside affects the y values. So inside x, opposite, outside y follow. And that's what all this says here, in just a smaller context. So if I give you a function that looks like this, remember this could be any function, it could have absolute value, x squared, x cubed, anything. The stuff on the inside affects the x values, and you want to do the opposite operation. Stuff on the outside affects the y values. You want to follow what it says. In a shorthand for writing that, sometimes IB would use a translation vector known as this. So AB. All this means is the top number affects the x, and the bottom number affects the y. So this is like saying HK. That's my h. So that's all that is. If you see translation for a second, we'll see some of that later. But that's all it is. It's saying this affects your x, this affects your y. So how much are you moving your x, how much are you moving your y. So let's do an example here. So consider the graph of y equals f of x alongside. So here's our graph. On separate axes, draw the graphs of this. So f of x equals y equals f of x plus 2. So the key thing here is what's it affecting? Well, this is on the outside. So it's going to affect my y value. So my y value, we're going to go plus 2. Or if you want to think about it as a vector, the vector would be like 0, 2. Right? Because on my x, I don't do anything, but on my y, I'm going to add 2. So for this graph here, all we're going to do is add 2 to all the y's, also known as move it up 2. So you can get a read point and move it up 2. So here, 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 here. I like to think about it like points. So let's say this point here is negative 1, 2. And let's use this point here as 0, negative 1. And let's use this point, that would be 1, negative 1. We use this point down here, which is 2, negative 3. And we use a final point there, 3, negative 1. Right, so these are the key points in that graph. And all I'm going to do is on my y values, I'm going to add 2. So for all the y values, we're going to just go plus 2. And I'm going to get negative 1 and 4. So negative 1 and 4. I want to add 2 to the y here. We're going to get 0, 1. Over here, we're going to add 2 to the y again. And we'll get 1, 1. This one, we're going to add 2 to the y value. And we'll get 2, negative 1. And the last one here, 3, negative 1, we'll add 2 to the y. And we're going to get 3, 1. Oops, wrong spot. There we go. If we connect all this, we're going to look like this. Now, besides my bad graphing, if you look at it, it looks like you got your graph and moved it up to. That's what this thing does. It moves your graph up to. So again, two ways to do it. You can just literally see the graph and go, okay, let's move every spot up to a little faster. Or, if you look at the points, the key points, you just add 2 to all the y's. That's what this is affecting. Let's look at the next one. We're going to do the same thing. Try to get all these out of the way. Okay. And on this one, it's on the inside, so this affects the y values. We want to do the opposite operation. So this is a pot we're adding 4, we're doing the opposite operation, we're going to subtract 4. Also known as moving left 4. So that's one thing you can do, is look at all these points and just literally move it left 4. So you get all the points and move it left 4 and see what your new graph is. If you don't like that, what else could you do? On your x values, you subtract 4. So we're going to go -4 on all these x values to get our new points. So this guy turns into -5 and 2. This turns into -4 and 1, -1. -3 and -1. -2 and -3. And -1 and -1. Right? All I did was inside opposite, so -4. I'm going to add -4 to all the x values. And I get these values. So -5 and 2. -4, -4, -1. -3, -1. -2, -3. And then -1, -1. We get this graph. Right? So it looks like the same graph just moved over 4 spots to the left. So that's what's going on here, right? Outside y follow, so this one says +2, so we're going to move up 2, all our points. Inside x opposite, so it says +4, so we're going to move left 4, -4, left 4. Or conversely, just add 2 to all your y values, so it's on the outside. Subtract 4 from all your x values, so it's on the inside. Okay, let's look at this one. Write g in terms of f of x. So what that means is, f of x is our normal one. How do we get g? What do we do to g to get that? It looks like we went from here to here. Like they just moved it left. They moved it, well in this case, moved it right 3. 3? Let's count. 1, 2, 3, 4. Moved it right 4. Right, so this point it gets there, you have to move it right 4. Nothing else changed. So, g of x is just f of x moved to the right 4. So remember, if we move to the right, it's inside x opposite. So I want to get f of x to move to the right, I have to do x -4. Like that. Right, you get f of x and then you do this to it, which means you add move it to the right 4. And you get this graph. That's what's going on there. Find the equation of the resultant graph of g of x when this graph is translated up 3 units. So remember what up 3 units does, right? Is it on inside or outside? It's up, so it's on the outside. Outside x to y. You follow it. So all we're trying to do is this, f of x plus 3. Like that's all this is. But what is f of x? All of this. So it's something like this. -x squared plus 5x minus 7 plus 3. Then you add up like terms, and you get -x squared plus 5x minus 4. So there we go. The next one, f of x equals x squared plus 4x minus 1, is translated 5 units to the right. So remember, right is inside opposite. So what does this look like? It should look like this. It's f of x minus 5. Right, that's what this looks like. Move to the right, inside x opposite. So how does it work on here? Well, what happens when you plug in x minus 5 in for this? It's on the inside, right? So it plugs in here and here. So f of x minus 5 is the same thing as saying x minus 5 squared plus 4 times x minus 5 minus 1. Then you simplify it. Let's simplify that. X minus 5 times x minus 5 plus distribute 4x minus 20 minus 1. This gives me x minus 5 minus 10x plus 25 plus 4x minus 20 minus 1. Add up like terms. 25 minus 21 is 4. Add these two up. So I get x squared minus 6x plus 4. Is what that thing looks like translated 5 units to the right. So stuff like that. I'm actually not sure if they wanted this or this. Last one. Suppose f of x equals x squared is transformed to g of x equals x minus 3 plus 2. What happens here is I want to know what these points are in g. I must have forgot to put that part there. So what is this in g? Well, the key thing here, I don't even care about this part. That part doesn't matter to me. The part that matters to me is this. What is this doing to my points? What's it doing to my x? And what's it doing to my y? Right, well, my x is doing inside opposite, so we're going to add 3 to all the x values. And on my y, we're going to add outside follow, we're going to add 2 to all the y values. That's it. That's all this tells me. I get what I get from here, and what I'm going to do is add 3 to the x inside opposite and add 2 to the y's outside follow. So this new point on my g of x is just going to be add 3 to the x, add 2 to the y. 4, 8. Add 3 to the x, add 2 to the y. 29. Add 3 to the x, add 2 to the y. So 5 and 6. And there you go. Those are your new points.